the empirical rule. You did the summer work, probably remember the empirical rule. If you didn't do the summer work, you should have done the summer work. It was hard.
It wasn't hard, it was just tedious, and there were a lot of things for giving.
I'm not sure your brother knew how to do it when he was in the class. Yep, that's exactly what we're getting into, yes. Yeah. Alright, so the empirical rule says if I have a normal distribution, so try to draw like kind of smooth going up on the top of a hill. The middle of it is mu. It's like it's a Greek letter, it's a U with a long tail. So it looks like that. And that means the mean. That's the average or the center of the distribution. So yesterday we talked about standard deviation. The standard deviation is really important in normal distributions. So that's like it's how the whole thing gets set up. So if you go one standard deviation to the right and one standard deviation to the left, so this is saying plus one standard deviation. This is a sigma, like a 0 with a hat on it, I guess. Like a lowercase o with a trim on its hat. This is minus one standard deviation. So we're going one standard deviation to the left. The empirical rule says is that 68% of the data is within one standard deviation either way. So just kind of talking through as an example, if the average IQ in America is 100 and the standard deviation is 15, let's say. So if I put 100 there, go 15 this way down to 85, 15 this way up to 115, that means 68% of people in America have an IQ between 85 and 115. So it's just telling you, like, this is how far you go to capture 68% of the data. So if I had a bigger standard deviation, this whole curve would have to get like wider. If I had a smaller standard deviation, it'd be like a narrower type of curve. Alright, then we're going to go, so let's say I go out to here to plus 2 standard deviations and minus 2 standard deviations. That is 95% of the data. So what we're going to start doing is like kind of piecing things together, and I think this is going to find someone with a lot of. So I can ask you right now, what percent of the data is in? What percent of the data is up there? 2.5. Good. So you got 95% of it is in between here and here. So there's 5% remaining. Well, that's split evenly, so that'd be 2.5 there and 2.5 there. What percent of the data is between there and there? It's this part right here. 68 is all the way from there to there. I'm saying just easily 34, right? Alright, don't say this one out loud because some people are faster than others. What about this? Between 1 and 2, like what percent's right between this part here? Don't say it out loud yet. You might need to calculate this one. Some of you will, some of you won't. So you start breaking it down and go, okay, well, this is 98%, right? But this was 68, so if I remove that 68, what's left? 27, and that 27 has to be split between here and here. So then what is here is half of 27, so 13.5. What do you have, 13.5? Alright, then the third one, so we go 3 standard deviations also. So plus 3 standard deviations, minus 3 standard deviations. So if you're beyond that, that's really rare. And that is 99.7% of the data. Your normal curve looks ugly? So we can start breaking this down, kind of like what we were just doing. So what would each of these two parts be? This part and this part both be 34, right? And then just kind of thinking through that process again. Well, between these two is 95%, but I've already used up 68% with the 34s. So there's 27% left to split evenly among these two, so they're both 13.5. And then do that same idea again. Well, 99.7% of the data is between, my pen and my finger. But I've already used 95 of it, so 4.7% is left over, right? I cut that in half. This is 2.35%. This should be percents on all these. And this is 2.35%. And then I can go one more. So out here, now we're getting really rare. This is like, if we were doing that IQ thing, it means 100, and let's say standard deviation is 15. I don't know what it is, but let's say it's 15. So this would be 115, this would be 130, this would be 145. So the percent of people that have an IQ higher than 145 would be tiny. So the data gathers around the mean, and the further away you get, the more rare, the more unlikely it is. So 99.7% is between these two, so what's left? Because it's got to have to 100, so what's left is 0.3%, right? So then over here is 0.15%, and over here is 0.15%. All right, questions on that? I'm going to ask you to study it for 30 seconds to a minute. I'm going to ask you to put it away, get out a blank sheet of paper, and try to draw it again without looking. If you just remember these three numbers, I think you can kind of make the rest just thinking through it. You have 1 minute. Study. Go. Pretty close. It actually becomes somewhat useless because we find out how to do it precisely anyways. But it's the same as a lot of things. It's the idea that it's like... Alright, close that, turn it over, put it away, something. Get out a different sheet or on your desk or whatever and try to recreate that entire thing. Try to make that whole thing that we just made with the percents in there and every part of it. You guys will get better at that. It's funny watching you guys draw normal curves at the beginning of the year. Everybody's terrible. But then you get better. If nothing else in this class, at least you learn how to draw normal. That's solid, actually. What? That's like a 76. Oh, I got you. disappointed. These normal curves are actually decent. I wanted to make fun of them. Here's the bed.
This is the best one I've ever made.
That's like
Normally,
really good.
Normally, it's really terrible.
Spraying out that.
It's not bad. I've seen a lot worse.
But it's not good.
He's like, oh, that there.
Oh, yeah.
What do you want to accomplish this year? What would be that?
I want to show up to class on time.
It's probably the hardest part of this last part. Remember you were saying like it felt more like elite than the other. So think about it. There were like 20 kids in our class. There's like 60 in that. So it is more. It's like a like a triangle. Like we're a little lower than. Alright, so when you're done, check it. I mean, you can check it with your own notes, or you can check it with this, whatever, but see how you did. How many were able to recreate it? Right. Without the Alright, so let's look at how we would use that to do problems. I'm just going to type. It's easier. It's faster. You guys should be writing. I don't know if, like, when the teacher's typing stuff, that's a good clue to write things. I guess I should go over things like that in an AP freaking class. I'll tell you what. This is the best Milan has to offer. We're in trouble. I'm kidding. Here we go. Yeah, we're gonna get into that again.
What did he say that for again?
What did he say that he was referring to?
Yeah, what was he referring to? What was the violent way?
Oh, like percentiles? I'm not sure.
Just letting something happen and seeing what happens.
Oh, yeah. He was mad that we just tried integrated math to see if it worked. But if you really wanted to know if integrated math worked, you have to have half the people not take it. So would you prefer that?
Yes. I mean, I didn't take any of this.
Use us as lab rats to see it.
Yeah, exactly.
I'm not taking any of these.
But if you think about it, they're still using this as lab rats. They don't know if integrated math helps or hurts. So, would it hurt? But everybody hurts. So you don't know if it hurts.
If everybody hurts, does anybody hurt?
Yes. But nationally, because if the standard was within Highland, no, nobody knows. But if it's at a national standard,
Everybody's special dash. Which is another way of saying no one is. So I'm gonna go through this with you. I'm just trying to find a marker of the right one. You're welcome to do it your own too. I'm not ignoring you. I'm trying to find a functional marker. I haven't really done anything with this. So I would sketch it. So your mean is 1,000. And then you're going to go 150 each way, bless you. And put like your little marks on there. So this is just the idea that like people clustered or data clusters to the center. So if I grabbed a random student, are they more likely to be closer to 1,000 or closer to like 500? More likely to be closer to 1,000, right? Because these are probabilities basically. So you can set up all your numbers here, and then you can answer these questions based on your numbers. So go ahead, I'll give you a minute or two to do that. Probably longer than a minute or two, I guess. 3 to 4, let's say. Is this what the con was, or was ours?
I was thinking of something else. The con was pretty simple.
I don't like art just because I like the school, so it's always hard. That's why you chose it over.
Sometimes I like to like watch a video. There's so much you can
Like
do.
paper and pencil actually.
So you don't have access to paper and pencil this summer?
Sometimes it's easier to actually
Usually,
teacher.
like stuff that you did physically, it's worded differently. It's easier to interpret and stuff like that.
So
The academy is
I just-
just
hot.
It's just kind of.
you don't like Khan's wording.
I like having an app.
Yeah.
That makes more sense to me though. The fact that you like can't find paper.
Well, we're not in school. We don't have any rules.
Yeah, there's no school supplies.
How would I know? How would I ever find paper?
Well, I have to go make my own after jogging.
He did that in my hour too. He's showing like weird project. Oh, he's like what's stuff just to explain. I was gonna take a video of it, and he's like,
Yeah.
97.5.
Yeah, I got 97.5. Yeah, that's what.
stop. I didn't know.
It's 68, and then you add.
Good to go, or are some people still working? Still working? Okay.
I can come in. What hour is it?
so let's look through these. Quiet, please. Alright. So once you, I think the easiest way to do it is just make your chart and just kind of put your numbers on there right away. And then you're just adding up all the sections. So above 1150, I'm just going to add up these three numbers. So that is 16%. What percent's below 1150 then? Don't add them all up. It could be 84 because above and below have to have 100%, right? So you can just kind of do it that way. Below 1300, well, I can do that two ways. I could add up all of these, so 1300's here. I can add up all of those, but that looks kind of hard to me. So I'm just going to add up these two, which will give me 2.5, and then if that's 2.5, what does all that have to be? It's got to be 97.5, because it all ends up 200. And there's nothing wrong with going through and adding all those up. It's just like a little more tedious, I guess. Between 850 and 1450, so again, you're just looking here and adding up these sections. So this is 68, this is 16 more, so that's 80%. Above 1450 is that 0.15%, so please, nobody should be talking when I'm up here. And then below 850, so I got three sections down here. Below 850 is the same exact question, or same exact answer as one other question. A, right? So that's like either shading this part or shading this part. And that's going to be 16%.
For C. Yeah. C.
C, I got 84.
Did I add wrong?
I got 83.
Oh, it's 83.85, yeah.
I rounded it.
Don't round that. Because if there's decimals there, I want to keep the decimals so I can see. Questions on that one? Let me give you another one with hopefully a little bit more tricky questions. Let's say the average IQ is 100 with a standard deviation of 15. Sure. Probability. Where? Probably x is less than 115 is equal to the probability that x is greater than what? Try those five. Yep. So 1 minus. In parentheses, is that what you're talking?
No, I was just making sure that was
exact spot to make it completely unreadable. Is that why you're asking that? No. I want an actual answer. For you said? Oh, yeah, I want an answer. I know I'm in the way. I'm just writing this, and then I'll move. You know what? No, not as well. As this? This is the worst thing you got. It's pretty good shit. I was like more excited about that place than actually turned out to be.
He's like, I invite you all the way out. And then he wanted to go look at the steak place. I was like, let's go to Black Rock. And I told him about it. He was like, let's do that. So now we're going back. So I can't.
Have you been there before?
Yeah. Not with my family.
I wonder experience through that.
Yeah, like I filled in for this team and the coach like took us all to dinner at Black Rock and he was like, you guys have more steaks. And I was like,
How many people?
the first time it was only like 6 girls. The second time it was like his family. It was weird. Well, like we're like really close with them. Like he considers him family. And he's like rich. He's not rich. He's another guy. He's making big.
The probability of X being greater than 130 is 2.5%. 1 minus 2.5%.
So 100%.
Yeah.
Okay. That's what?
The standard deviation is 15. So if you go up, it's 150. If you go down, it's 85.
Oh.
So
Same thing.
Yeah, I did that.
It's just like flipping it to the other side.
I don't understand.
I was doing that. I was doing 1 minus 2.5. I'm so confused.
Well, 1 minus 2.5% is technically 1 minus 0.0.
It's like 0.
0.025.
Yeah.
Okay, question, or you just like stretch it? Okay. Go for it. So during a test, you just sit there. That's like you need extra power.
Davis. Negative.
Who's gonna answer?
Yeah, it's free. Yeah, I told him it's not doing that. He didn't listen.
I said who's gonna answer the long correctly. Please.
I just gotta excuse me. I'm going to Tennessee.
Oh, that's cool.
I'm super excited. Where is it? Detroit. They're taking I'm putting I don't know where at Detroit this stuff.
Like what building or whatever. Yeah. I did that last year too, I remember. It's cool. Are we good to go through or not yet?
Yeah.
Yeah?
Yeah.
No, not yet.
Oh,
It's CMP.
It's what? It's not conword. So what you mean by conwording is you don't understand it. So then it's con's fault. Okay. So probability of x is greater than 130. We just add up these two sections, so that's 2.5%, right? So that's just kind of reading off the chart. Probability x is less than 115, so that would be like from here back, is equal to the probability x is greater than what? So think about, okay, I went 1 standard deviation to the right, and then I took backwards this way. So the opposite of that would be going 1 standard deviation to the left and going up that way. But wouldn't those give you the same exact percentages? Like those are the same size, right? So less than 115 would be the same as greater than 85. So I'm trying to get you to like work with the fact that everything's symmetric. 85 is less. So this is saying the probability x is bigger than 85 and smaller than what? Gives you 81.5%. So 85 to here is 34%. If I go one more over, now I'm at 68%, right? If I go one more over, now I'm at 81.5%, so the answer I was looking for was 130. Does that make sense what I'm doing there? Did I eliminate the con wording? Are we okay? Okay. So it's like between 85 and what gives me 81.5%. Alright, probability x is greater than 130 is the same as the probability x is less than what? So again, the symmetry. So 130 and up is the same as what and down. Would be 70, right? So 2 standard deviations and higher would be the same as 2 standard deviations and lower. So now it's 70. On the bottom one, just this is kind of what the AP would do. It's the same questions I've been asking, but it's in like the con wording or the AP wording, and they're just trying to like take a normal question and make it as screwed up as possible. So let's start here. Probability x is greater than 130. Is that, right? 130 and that way. Well, what does 1 minus do? Doesn't it make it go the other way? So this is 2.5%. 1 minus that is 97.5%. Well, now we're going this way. 1 minus just flips it the other direction because we have to add up to 100%, right? So then the question is, now it's basically x is less than 130 is the same as x is greater than what? So I think that's a little easier now. Yes? So x less than 130 is the same as x is greater than what? 70. Because you get that same, the same size either way. Does that help? Like if E was confusing, does that help? You said eh? Let me do it again.
Can you explain B? Because I don't know why you just can't add up the numbers that we did last time. You get 85 with the other numbers, you get 84. It's not a percentage. Oh, it's actually.
Yeah, I'm not looking for the percentage. I'm saying the probability x is less than 115, which would be all of that, is the same as the probability x is greater than what? So I want to know, like if I put 100 there, is 100 and above the same size as the 115 and below? I'm trying to match up and say the probability that x is less than 115 is the same as the probability x is greater than what? So what number would I shade above that number and have the same size? Would be what? Do you see that? And that's what I'm asking. I'm not saying like find the probability. I'm just saying like fill in the blank to make it to the P. Does that help? Okay. Other questions? Alright, there's in that packet I gave you your homework, and so realize some of you have started to see I'm like halfway through grading your tests. It would go faster if you guys had done I'm going to slow down more than I was hoping, but it is what it is. But I think some of you are starting to see what, okay, this is what a test is going to look like. I better do my work to make sure I'm eligible for the retake. So this is the first thing that would make you like eligible. You know, I'll check this tomorrow, and if you don't do it, you're not eligible for corrections or whatever. So the first 3 pages on the package, like front, back, front, not 3 front and backs, just front, back, front. Front, back, front. It's your homework. So it's just the stuff we learned. Front, back, front. If you get into Z-scores, you've gone too far.
What if it's skewed?
Back, front, front.
Then none of this applies.
Average, front, back.
This is all for